A very good morning, all. Today we'll be just looking into an interesting topic, which is thermodynamics and some of the important laws of thermodynamics. Before getting into the laws, we should know some of the basic. We should know some of the basic things on a thermodynamic system, which is what a thermal equilibrium is, what a mechanical equilibrium, what a system is, what a surrounding, when a system can be called as an open system, closed system. So only after knowing all these things, we can move into the laws of thermodynamics. So at first, let us know what a system is. Right. So a system is nothing but a definite quantity of matter bounded by some closed surface. So a quantity of matter can be anything. It can be a gas, a solids, or liquids. Any quantity of matter bounded by some closed surface is said to be a system. And if I have the same kind of material, for example, if I have a mixture of gases, then throughout the system, then I'm just going to call that system as a homogeneous system. If I have two different phases of matter inside a system which has been separated by a boundary, then I'm just going to call that as a heterogeneous system. So this is a system. Then what is the surrounding? Anything outside this system which can actually exchange energy with it. We call that as a surrounding, right? So a system is a definite quantity of matter bounded by some closed surface, and a surrounding is anything outside the system is said to be a surrounding. So together we call the system and surrounding as a universe. So this is the idea of a system and surrounding. Now, there are three different classes of system. One is an open system, a closed system, and an isolated system. The open system is nothing but it can actually exchange energy as well as matter. It can exchange both. We call such system as an open system. If a system can exchange only energy but not matter with the surroundings, in if that is the case, I'm just going to call that system as a closed system. If the system cannot exchange either matter or energy with the surroundings, I'm going to call that as an isolated system. So the first one is it can exchange both energy and matter. It's an open system. It can exchange energy alone but not matter. We call that as a closed system. It cannot exchange both matter and energy. We call that as a isolated system. And I have just given figure for open system, closed system, and isolated system. The first open system is a boiling water in an open vessel, right, where exchange of energy as well as matter will happen. Whereas the second system, which is a closed system, where energy will occur. So we call that as a closed system. And the third one is an isolated system. And the best example can be a flask where either the energy or matter, they will not get exchanged with the surroundings. So these are all the three different classes of system. And we have three different equilibrium. We call that as thermodynamic equilibrium. So the first one is a mechanical equilibrium where there is no macroscopic moment. So within the system or between the system and surroundings, which means in this thermodynamic equilibrium, and between the system and surroundings. So a mechanical equilibrium is one where there is no macroscopic moment. A thermal equilibrium is one where there is no temperature difference within the system or between the system and surroundings. A chemical equilibrium exists when the chemical composition remains constant, which means there is not going to be any kind of chemical reactions in it. And also, we have there is no movement of any chemical constituents. So these are all the different thermodynamic equilibriums, right? Mechanical, thermal, and mechanical. So let's we can just move to the zeroth law of thermodynamics. So at first we have discussed what a system and what a surrounding is. Then we have just slowly get into a open system, a closed system, and an isolated system. And now we have just seen what a thermodynamic equilibrium is. So we have mechanical equilibrium, chemical equilibrium, and thermal equilibrium. The next, with this idea, we'll be just moving into the next topic, which is the zeroth law of thermodynamics. I think you can here where we have three systems A, B, C. So here, system A is in thermal equilibrium with system B. Similarly, system B is in thermal equilibrium with system C. Right? If A is in thermal equilibrium with B and B is in thermal equilibrium with C, then obviously system A will be in thermal equilibrium with C. Right? So we can state the zeroth law of thermodynamics like this, which is if two systems are in thermal equilibrium with the third system, then they are in right? So the thermal equilibrium between three different systems. So this is all about the zeroth law of thermodynamics. Now, the first law of thermodynamics. So here you can just see the figure where we are just actually giving some heat. We have right? The amount of heat given is converted into internal energy, and it's partly used to increase internal energy and partly used to do some work. And we're just going to give the first law of thermodynamics in a mathematical relation, which is Q is equal to del U plus W, where Q is heat absorbed, del U is internal energy, and W is the work done. So this is the first law of thermodynamics. Some significant aspects, some implications in this law of thermodynamics. The first one is let us first discuss the significance where it is applicable to any process by which the system undergoes a physical or a chemical change. And also only this law introduces a concept of internal energy, and also it provides a method to determine the internal energy. So these two are the significances of this first law of thermodynamics. And now coming to the limitations, this law does not specify condition under which the motion of the programs. And also this not specify how the energy is available. Yeah, some of the limitations the law of programs. So that is so a Carnot's engine is something uh, which actually works between a high temperature reservoir and a low temperature reservoir. So it's nothing but a heat engine. So this source is nothing but it's a hot reservoir, right? And also we have other term which is said to be a sink, which is said to be a cold reservoir. So this will basically because and we have the next part of Carnot engine, which is sink, which is going to be a low temperature reservoir, which will be maintained at temperature T2, and the working substance release all the heats to the sink. And the third important part of a Carnot engine is a cylinder. So a cylinder with a piston, and we should be having some gas as a working substance. So a hot source, it is placed in contact with the cylinder for absorption, and a cold sink is placed in contact for rejection. And along with this, also there will be an insulating stand, right? So these were all some of the important parts of a Carnot engine. So today we have discussed what a system is, what a surrounding is, what are the three different types of system, and what are the three different types of thermodynamic equilibrium. And slowly we just get into the zero law of thermodynamics and first law of thermodynamics. And finally, we just end up with some important parts of a Carnot engine, right? So this, we can stop here. We can just move to the next topic.